Welcome to Madibeng STEM project. Guys, today we're going to do Newton's second law of motion. So basically I will be doing tension, I will be calculating tension on the rope. So I want to show you how to calculate, how to do calculation when you deal with tension or rope, or rope connecting two objects together. Like in this case, you can see here we have Michael here. Michael is pushing, is pulling these two objects. And object A, it has a mass of 12 kg, and object B, it has a mass of 24 kg. These two objects are connected with a rope. This is a rope, guys. So what you should know about tension, guys. For example, if I have an object here and I'm pulling this object, and I'm pulling this object, when you pull an object with a string or a rope, guys, you need to know tension will act away from the object. If this is an object of 2 kg and I'm pulling this object with a string, so you have to know that the tension is always acting away from the object when you pull the object. You understand? So when you push the object with a steel rod, this is a rod, it's not a string, guys. And now instead of pulling, I'm pushing this object. So when you push, tension, this is not tension, compression. When you push, the force that you apply here is called compression, and when you pull, it's called tension. Because you press, you see, you compress, you're pushing it, you're not pulling it. So when you push, the force is called compression, it's not tension. So here, when you pull, it's tension. Now it's acting away. This is tension. Tension acts away from the object. And when you push, you compress the force, when you push that force at the object with the rod, this is not a string, it's a rod. When you push this object with a rod, this force is called compression. So now this compression force is acting towards the object. You see, in this case it's acting away, in this case it's acting towards the object. You need to know these things. When you pull with something with a string, the force or the tension, it will act away from the object. But when you push, compressing that force, you compress it, it acts towards the object, like this one, you see. So in this case, we are pulling. So here tension is acting away because we're pulling these two objects. So I want to do calculations to find the acceleration of the system and also find the tension between these two blocks. The tension that is experienced by this rope between these two blocks, block A and block B. So what is it that we're gonna do? What is the first thing that you should do? You should determine the forces acting on this object A and also object B. So let's go ahead and do the diagram force. Free body diagram force. This is object A with a mass of 12 kg. So we know that when you pull something or when something is moving, there is a frictional force. As we were told that the system is experiencing 0.3 of coefficient of friction. You understand? So it means there is a frictional force. So in this case, frictional force, it will be this side. Fk. Fka. This will also have Fkb. Fkb, meaning frictional force that is experienced by this object B, and this is a frictional force that is experienced by this 12 kg block. So first thing we have to do is to draw our free body diagram to showcase the forces, all the forces that act on this body. We know obviously this object, it has weight because it has a mass of 12 kg, so it will have a weight, and there is also normal force. So there is a weight which is WA, and there is normal force NA. We have frictional force FKA. We have tension, which is this string is acting away from the object. Tension is acting away from the object. So we finished with this one. So let's go and represent these forces here to our next block, which is 24 kg block. So here we have a 400 force that is pulling this two blocks, this system. So we have 400 Newton force that is pulling this object. So there is also a frictional force. There is also weight. There is also normal force. NB, WB, this is FA. So there is also tension. So tension in this case, in this block, it will act away from this block. So when we deal with this, tension is acting away. So even to this block, tension is also acting away. You see, this here is tension, it's acting away. Here is tension, it's acting away. You understand? So we also have frictional force. FKB. So now we can see all the forces that our two objects experience. So let's go ahead and find all these forces. Let's go and calculate our weight for this object and our weight for this object. Let's go ahead and calculate our weight. So in this case, let me do them here. Weight for object A, is mass times gravity. You know the formula for weight. It's mass times gravitational acceleration. So our weight here is 12 times 9.8. So for object B, our mass is 24 kg times 9.8. Twelve times 9.8. 117.6 Newton. 24 times 9.8 is 235.2 newtons. So we have weight. Weight is also equals to normal force, guys. They are equal, but they act in a different direction. So this is also equals to our normal force for this object B, and also for this one is also equals to our normal force. They are equal, but they act in a different direction. So now that we have our weight, we will have to calculate our frictional force for this object and also find the frictional force for this object. Let's go ahead and find a frictional force. For A, FKA over normal force. So let's go and substitute. What is our coefficient of friction? Is 0.3. So we don't have Fk, we want Fk. Divided by normal forces for A is 117.6. 117.6. So we make Fa subject of the formula. Fka is equals to 0.3 times 170.6. That's 35.28 newtons. So I don't have space, guys. I need space. So now we want Fk for our object B, which is coefficient of friction times normal force. It's for A, not it's for B, not A. So 0.3 times normal force is 235.2. 0.3 times 235.2. So it's 70.56 Newton. We have our Fk. So now we have Fk for this object, we have Fk for this object. Remember, to calculate acceleration, it means we will have to deal with horizontal force, not vertical force. So weight and normal force are vertical forces. They are vertical forces. So we want to deal with horizontal forces. So what are the forces? What are those forces that we will have to deal with? Is Fk and tension, and also F applied. You understand? So let's go and formulate our formulas for this system, for this block A. We know that the F net is equals to the sum of the forces acting on this object or this object, the sum of the horizontal forces acting on this object. So what are those horizontal objects? What are those horizontal forces that act on this 12 kg object? We deal with this 12 kg object first before we can deal with this one. So let's deal with this one first. So in this case, in horizontal, on our horizontal, we have Fk and tension. So here F net, we know that is mass times acceleration. So now the total forces acting on this body is Fk is T, which is Ta minus Fk. Because I'm taking this direction as my positive and I'm taking this direction as my negative. So every force that acts on this direction, I will take it as positive. So what acts on this position, on this direction here, is tension, and friction is going in an opposite direction. So this one I will take it as negative. So TA minus FKA. Let's go and substitute. What is our mass here? It's 12A. Is equals to TA minus, what is our frictional force? For A is 35.28. So this is our first equation. We formulate this equations. So this is equation 1. So I'm going to this one. I'm going to this object. So let's go, and F net is equals to the sum of the forces acting horizontally on this object. So we forget about this one for a little bit. So we focus on this one. So what are those horizontal forces that act on this 24 kg object? We have this force, applied force here, is acting horizontally to this object. And we also have our tension that is acting away from this object. And we also have this Fk, which is frictional force that is experienced by this object alone. So let's formulate the equation for this object. So now this is for A. This is for A. This is for A, object A. So this is for object B. So F net is equals to mass times acceleration. So what is all the forces that act on this body? We have 3 forces now. We have tension, we have a frictional force, and we also have applied force. So we can see that applied force is going to our positive direction, and our FK and tension are going in an opposite direction to our applied force. So let's do this. It's F applied minus into tension B plus frictional force for B. So now I will have to remove this brackets by multiplying my negative with my positive here to remove this bracket, and also to multiply with this one. I'm distributing this negative sign to this term and also this one. So by doing that, I'll multiply -1 by +1. It gives us negative TB. So we will end up having 24A is equals to FA minus TB minus, what is our frictional force? 70 minus 70,56. This is our equation 2. So we have 2 equations now. We will have to equate these 2 equations. To eliminate so now, instead of leaving our answer like this, let's go and substitute our FA, because now we have our FA is 400. this is our first equation, which is 12a is equals to TA minus 35.28. This is our first equation. So we use elimination method. So now we have 24a. First, let's go and solve this first. It's 24a. This is 400 minus TB minus, what is 400 minus 70.56? 400 minus 70.56. 400 minus 70.56. That's 30. So now we will end up having this 3 I want to, where is my, okay, minus TB plus 3 to 9.44. You understand where I got this one? I got this from subtracting 70.56 from this 400, because they are constant numbers, so they are like terms, so we have to subtract them. We can't leave it like this, so we will end up having this as our equation 2. Here it was not finished. Yeah, this is our final answer. Yeah, so we will apply elimination method to solve for A, which is acceleration. So guys, now that we have our final equations, we have these two equations though, so we will have to apply elimination method by adding these two equations together so that we can eliminate our t. So if I add these two, then this will cancel this. If I add, it's an addition method, not subtraction method. So here I'm adding this 12 plus 24. 12 plus 24, it gives us 36a. So now when I add my ta plus tb, it's 0. T plus minus t, it gives us 0. So it's 0. So this will eliminate this. So what is minus 35.28 plus 329.44? It gives us 29.4.16. So now we will have to divide both sides by 36 to be left with a. So this cancel this. So divide by 36. We will have a is equals to 8,17 meters per second This is how you calculate your acceleration. So now to find the tension on the rope is gonna be easy, because we have these two equations now. We can use either this one or this one. You will choose between the two equations, because now we have our acceleration. We will have to substitute our acceleration with 8,17. Then we will be left with TA. So now we can make TA subject of the formula and get the answer. Let me do it, guys. Let me do it for you. Let me do it for you. Let me cancel here. So let's take this equation number 1, which is 12A is equals to our tension minus 32.28. So now we have our acceleration is 8.70. So we make T our subject of the formula. So it means I'm taking this one to this side. So this is, what is 12 times 8.17 is 9.04 plus 32.28 plus 32.28. I got 130.32 newtons. That's my tension between the two objects. The tension that is experienced by this rope. Guys, this is not 32, it's 35. I've made a mistake here. This is 35, not 32, guys. So instead of 32, let me fix this. This is 35, 35, 35. Yeah. So what is 98.04 plus 35.28? It gives us 133.32 newtons. This is our final answer. This is the tension that is experienced by this rope between these two blocks. It's 133.32. That is our final answer. This is how you calculate tension. It's a lot of work. You can see it's a lot of work. It will take you at least 6 minutes to do this one. It's gonna be 7 or 8 marks. So it's a lot of things that you have to do. It's a lot of things that you will have to remember. Remember, first thing you draw your free body diagrams. Then now you determine all the forces that our objects experience, and then after that you follow the steps. So after that you identified all the forces acting on the object. Now you will have to formulate the equations by substituting all the forces that act on the horizontal to our object A and object B. Remember, you do them separately, then now you will have to add the two equations together so that you can eliminate tension and be left with acceleration. Then after that, you will now have to substitute this acceleration to one of these equations. Here, you see me, I chose to use this one. It's not like if I choose the second one, I will not get it right. I will get it right even though I use this second equation. So it's up to you which equation you will have to use here. It's up to you guys. So this is how you calculate tension, guys. I hope you got everything here, guys. But I will be doing other examples. So thanks for watching the whole video, guys. Thank you so much, guys. I love you guys.